Hello everyone, what's up? How's it going? How are we all doing? Welcome. So last stream we made some good progress. We got the ability to when we run the game, it can tell us all of our input devices that are connected, right? Which includes gamepads and multiple keyboards and multiple mice. So we'll go ahead and plug this PS5 controller in. Oh. I just spilt some stuff over my desk. Oh well, okay. Eh. Wait, let's make sure the camera's still good. I guess. Hey, I'm kind of see-through. That's fine. We can live with that. So we're plugging this PS5 controller into one of my USBs. And then if I run the game again, as you'll see, we get the PS5 controller. It also comes with some extra features. It tells us it's got a touchpad, right? It tells us it's got a keyboard, no, a gamepad, accelerometer, and I think it doesn't tell us it's got the gyro though. But yeah, so I hope I paid for that PS5 controller. Yeah, I paid for my PS5 controller. Of course I did. But I got this one for free. Free work. They gave all Sony employees a little special edition, like Play Has No Limits controller. Don't know how well you can see that. That looks horrible on the camera. But yeah, it's because the green ones go invisible, don't they? But yeah, imagine they're green, the see-through ones. But anyway. How's it going, Perry? How you doing? How's my Perry boy? Hey, Glorissa. How are we doing? I need to get my Xbox controller from my parents' place so I can plug that in and see if it works the same. I'll see if I don't know. Glad this week is nearly over. Oh yeah. No, it's Friday tomorrow, isn't it? Yeah, I'm not doing bad, man. Not doing bad. I had like a real genius idea yesterday while I was at church for work. And then I got into work today and I started doing it and I was like, oh no, my genius idea has to like be changed. But it was nearly good. It was nearly... Yeah. I had to execute my genius idea and now I'm fighting with compilers at work. So my day's been going okay. You know what I mean? Like, life is so much simpler when it's just an idea. But yeah. Yeah, so today we're working on hot plugging support. So we can see this input connected thing, right? Hop into the main file, what do we get? It's coming from here. So we're able to send out events when we boot the game, but not when we have it running. So we're going to be adding that support today. But yeah, I think so. The baby's due date is 10 days, so it can come anytime. So next week is a pretty likely week for the baby to come, and I'll be taking a week off stream, so I can get used to the thing, you know, and understand the baby, and have a bit of fun as well. Probably staying up really late. Right, so we need to probably go into the os.h, and then we'll go into the os Linux. Right, so basically we use udev, right? Okay, we use udev to enumerate over all the USB devices, and we figure out its capabilities. Wait, before we do hot plugging support, can I see if I can get that gyro thing to work actually? 2 seconds. 2 seconds. I think I can try this. Right. Because we did this last stream, and so I want to just print out like wait, we'll just do a breakpoint so we get a sig trap on it. So this is how you check for gyro. You gotta like, literally rocket science. So basically, let's run the test program, which we've done for udev to print out all the properties. Basically, there's this thing called ABS, right? I don't know what it means. It means something. Oh, what? Oh, is this any printing ones called event? It can't be. I remember seeing some AS. What? Get property, prop, ABS. That did exist. Oh, because my controller's not plugged in anymore. Hey, EGR. EGR. How you doing? Welcome. So run the test program again, and then we get to actually find it this time. So yeah, so basically like you need to check. Yeah, so it's on this input one, input 24. So I think, and but it's not on the one with the event node, or it's called device node, but with an event file descriptor where you can actually read the events from. And this is the parent device, I think. So I'm going to try and see if I can search for it here. So the ABS has some bits on. So that's like the first 4 bits on, first 6 bits on, right? That's F is 4 and then 3 is the lower 2 of a nibble, right? So if you go to here, these are the first 3, these are the next 3, right? So obviously the last, so that's 6, yeah? 6 of them are on. So hopefully I'm going to search for input and see if I can get that one to trigger that breakpoint for us. We didn't hit the sig trap there. Do we get one with an ABS at least? We don't get one with an input? An ABS, what about with an input? Okay, we hit the trap there. Oh, that's fine. Input 24. Child 3, apparently it should hit that. Sys name. Oh my days, this should be equal to 0. Okay, there we go, that's why. Do we hit the sig trap? No. Right, what about if it has the ABS property on it? Okay, we hit that. So I guess something's wrong with this checking here. And then that should be able to check for if it's got the gyroscope enabled, basically, on the controller. Hey, Freddy the Revenge. How old am I? I am 28, I think. I think that's right. Hey there, Max Kura. Hey. How's my day going? Yeah, it's going alright. It's not going bad. It's looking bad. Thank you. Yeah, just been trying to get stuff working at work, basically, just fighting compilers. you know, that sort of business. Yeah, day's been going good. How's your day been going? Nice debugging. I know, Perry. All the skills. So let's print out our thing. ABS equal a string. And then print out the prop value. And let's just take a little look at that. Right, so we are getting it with that 3F1. So we are reaching it. It's just this checking code here is wrong. So what we're going to do is we're going to put that breakpoint in, and we're just going to follow it. So it's the first one, right? So we just open up GF, and then we write our breakpoint. There you go. I love that. I love that function. It's great. So the string size as we came in is 5. That's right. 5 characters. We're good. So rather than turning the string into a number, what we do is we just parse the string, turn the character into a number, and then just do it that way. So that's all this function does. So the bit word index you're looking at, so your bit index is like 3, isn't it? Yeah. So gives you F. 15. That's good. So we can do that. Is 3 on? And that should be a yes. Right, word is 15. So that's obviously all bits on. That's 4 bits, right? What's if left 3? Yeah, it should hit it. So I went into the next one. Good. So this one goes over to the next word. See, why did that get F again? Right, it's every 4, isn't it? Every 4 is a character, not 8. There's the problem. Because it's hexadecimal, right? 4 bits per character. Right, let's try that one out, see what we get. So I guess you see we hit the breakpoint now. If so, it's yes. So it found it in the string now. So we should be able to remove this, and then this should say. So you know what? Let's comment this one out, and let's put this breakpoint here. I want to see if it hits this gyro one. No, it doesn't. Okay, that's good. So now. Well, you can just enable the fact that it's got a gyroscope. But I want to... So I don't know if the gyro has a dev node. We'll have to figure this out later when we parse the gyroscope events. I'll figure out where those are. I don't know where they come from. So it's just going to not say anything. And then we'll do a continue. Right, so now we've got 3C instead of 1C, which means that's the gyro bit enabled on the features for the controller. So that'd be proper cool. Right, so that's everything I want. So now we can actually work on the hot plugging. Hey, Omos61, how you doing? Love what you're doing. Did you by any chance forget to upload the most previous session to YouTube? I'm pretty sure I did it. Let's take a look at the VODs. Maybe I made it private by... It was private. Right, I'll have to hop into the channel and sort that out. I'll sort it out after stream. Thank you for that. Because I upload them directly from Twitch. and I must have left. It says you can put it in public or private, so I must have left its defaults to private. So that must have what happened. I'm also going to rename these guys as well. So be wary. I'm going to rename them to something a bit better than part 1, part 2, part 3. I'll give them more descriptive names to what they are. Yeah, I'll do that all tonight. Yeah, what a scrub. Oh, Bassandro, thank you, sir. Cheers. Is there an archive of 1 to 12 on this journey? Yes, sir. You can, yeah, there is a shortcut to that. You can just type VOD like that, and you get access to the VODs there. Yup. Thank you, Glorious Sir, for the link. Appreciate it, sir. And thank you for this sub, Bassandro. You're the man. Or nowadays, you're the person. Oh yeah, yeah. I've seen some people call their stuff like that, and I don't know if that's for the lols or not. There, Bassandro. Right, hot plugging time. So because we use udev, right? There's a monitor API. So libudev, which is built into the operating system, basically. Isn't udev part of systemd or something? I don't know. For all those systemd lovers. There's this monitor API. So the biggest problem is like every frame, you don't want to be going over every single connected USB device and then scanning over all of their child devices and picking up their event nodes and stuff like this, right? You kind of want to have a more sort of like the system tells you, hey, here's a new connected device, then you just scan that single device, right? So what we need to do is we need to use this API. So I just need to figure out how the hell to do that, basically. New from Netlink. See, I'm not familiar with all of this. So I'm going to take a look at some other code and see how to use it. Is now part of system B. I think it was standalone before. Fair play. Ah, udev. Ah, yeah. It came. All right. Yeah. Yeah. I only noticed this because I saw it as part of the systemd project the other day. So let's take a look at the SDL code base because they end up using this thing here. It's going to be different to theirs though because the way we do ours is we look at the USB devices and then look at all the child devices for that USB device and see if it's a and get its like event. It's different event file descriptors that we can read from, right? Because the PS5 controller, it has one file descriptor to read the button and analog events from, right? A different one for the touchpad, a different one for the accelerometer. Wait, accelerometer, that one. And then the gyro's on something that I don't even know, right? And we've got to figure that one out. So basically, like, we take all those different file descriptors and chuck it into one input device because it shows up as like 4 or 5 different input devices with one parent device, which is the USB thing. So I just want to take a look at the SDL code base for the udev thing because I don't know how to use this API, this monitor API, and I saw it in here when I was taking a look. So they do a new from Netlink and then just put the word udev in there and then they get this monitor thing. So we probably want to do this at boot. Yeah, when we boot up. So we'll do this. Source OS Linux. So you're developing the game, but game engine by itself, or along with a demo game. Right. It's called Game Without Engine, not Engine Without Game. That's a good way of saying it. Yeah, it's called Game Without Engine. We're running a game, but we're just getting the essentials together. So we've done a graphics layer. So we've got GPU. We've got a GPU system. So we can talk to the GPUs in Vulkan. It can be implemented for other platforms. It just uses compute. So we've got three different compute shaders here. One's the background, one's this triangle, and one's this image. So that is basically ready to be demoed. Sorry, for us to do our graphics R&D with. But we kind of really neglected the core part of the game, or the engine part, right? The core engine part of the game. So we're just coming down and just sorting that out right now. So the first core thing was actually getting custom memory allocation. We did that like 4 streams ago. And then this stream, or then the past 4 streams as well, we've been doing keyboard input. And we've got a first version in, but then was like, hang on a minute. We want to do controllers, and we saw you could attach multiple controllers. So I was like, why can't we attach multiple keyboards? So we've been sort of exploring this territory and been going down a bit of a rabbit hole. But after this, we're going to be doing some UI, custom UIs, because we can do some custom tooling for the game. And then we'll be doing some graphics R&D work in 3D after we've done a little quick UI that we can use. So that is the quick TLDR of the plan. Any thoughts on Raylib? Yeah, if you're coming down from the web side of things or new to programming and want to use C, it's a good thing to sort of just get stuff on the screen and learn the language and sort of, I think it's pretty decent at that. Yeah, like something to take note is we're not doing multiple Windows support as an example, because I don't think this game is going to need it. So by doing a game of an engine, we can skip that part. And, in the future, if you want to do another game, you just copy paste the game and take the bits out, add bits in that you need, right? This is the method. This is the sort of thing we're trying to explore. Is this method of doing things a good idea? Because the best thing about it is you get the whole code base, you can just change it, right? And it's really flexible in that way because you have access to the whole code base. There's not someone else's thing you're using. It needs more than one window, exactly. That's 2 applications, right? What is the game about? We want to do some graphics first. So we want to find an art style that I think we can use for a 3D game. And then when we have that art style and something that looks good, we're gonna like use that as part of the input to what is this game idea, right? That's the idea. Because if I came up with a game idea right now, my thoughts of that game idea is gonna change by the time I actually get to doing it. So it's just best if I think about the game idea when we actually get there. So we're just gonna get some essentials together now. Change anything anytime, and there's less of a troll because it's just one game engine, not all for all the people. Yeah, that's another point as well. Because if you change the sort of engine part of the game, you don't have to worry about it working on like everyone's game who's using the engine. Yeah, that's right. Just every platform that your engine runs on. Right. Hey there, Don. How you doing? How's things going? How's the past couple of streams been? I've been able to catch it because there's been meetings. Yeah, how's it going? Doing well, pleasantly broke. Well, at least you're happy and pleasant. Yeah. Yeah, no, it's tough right now, isn't it? Prices are like up, up in the air. Food bills in the UK are just ridiculous. Um, but yeah. Yeah, I hope you and the family are doing good though. Everything's all well in that hood. Bought a tractor. Oh, yeah, I remember you saying bought a tractor. 50k. My wallet hurts. Yeah. Speaking of engines, Don bought a tractor. Is it one of those ones you can mod, or is it like a got a very locked down piece of gear? Engine's the right choice for most developers, but it's not fun. Such people really don't make a game, in my mind. Yeah, you know, you would hope people who don't write engines have the ability to focus more on the game, but that typically doesn't end up being true. You know, so they can make a good game. You know what I mean. But there's still a problem with you. Yeah. About multi-monitor setups using DWM, stuff like that. Finally switched noticing. I saw notice in my. Nice. Yeah, I used to use a tiling window manager. They're pretty decent, pretty fun. But yeah, I like the single monitor setup because, yeah, just get less distracted that way, I think. I better be re on it for that tractor. Does it run C? Right, so we've got this monitor thing here. So we just want to set up that monitor. So when you do your udev, when we initialize our udev, we also want to basically have this line here in our code. And I think these things can return null. Which is, yeah. So I think we want to probably assert core assert failed to initialize udev, and we'll do another one, udev monitor. So now with the monitor API, how do we use it? So let's see how SDL does it. Yeah, so they match these subsystems, input and sound. We're not going to do that because we want to use the USB subsystem and do it that way. So we want to look out for the USB one and maybe match on a property, hopefully. So that's the way we want to roll. Oh, and then you enable receiving. Excellent. So we should be able to use something similar. So, right, so, wait, what am I doing with that? Yeah, in their code base, they use function pointers, and the reason why they use function pointers is so they can optionally have it as a dependency rather than it being a linked dependency at compile time, right? You know, there's basically no difference. It's just, except for in code, it's just more explicit, more manual, right? Is all. So we want to do a USB subsystem check. Now I want to just. You can't match properties, which sucks. So I think we'll have to match the property. So I want to go to my test. There's a dev type, is there? So I think we have to manually check for that dev type thing, USB device. We'll see. But anyway, so we've enabled that now. We'll get rid of the sound one. So with our monitor set up, Right, so that sets up the monitor thing. Let's put that in a little separate thing there. Now let's just check how you poll it. Right. Hot plug available. What does that do? While hot plug update available. I wonder what they do to achieve that. Oh. So it gets the file descriptor. IO ready. So I guess the monitor could get deleted or something, and then it would break this. Right, so I don't know if we need to do that. Should we check to see if there's another example to see if they udev monitor API example. And let's see if they have that problem. Example 3 is the monitor API. No, that's awesome. You loaded Quake 3 on it and Doom to stress test it. Sweet. You should have left it in there and made it like the Teslas of tractors where you can play games on it, you know? Right, so they get the file descriptor and they... Literal rocket science. Right, so you have to make sure this is all... Right, this is what we have to do apparently. So then we can say receive the events. Right, so they do receive device. So this basically checks to see if there's something on in the device. Then so they use this API to check whether it's got something it can look at. Right. So we want to basically say while this is true, right? So in SDL's case, they have something like this, where they do that sort of IO ready thing. Right. Okay. I got an idea. So we want to get this sort of like monitor file descriptor. I guess we'll just cache that. You know, it's maybe like, it's maybe at that pointer anyway, right? It's probably inside this udev monitor structure anyway. So maybe storing it locally isn't really that much of a big deal. So maybe we'll just say like, so make a nice little function. So go into the internals. We want to just say like udev monitor has event. Okay. And then we'll just just be a void, and we'll sort that out. So basically, we just want to call this thing, get the file descriptor, fd. So we need to get the OS backend, right? This is Perry's favorite part. And then we want to get from the udev monitor, get the file descriptor. And then we need to use this API, this thing here. And this will tell us, is that an int for a ret? Yeah. What's FD's about? I need one of these sets as well. I have no idea what this does, by the way. Select probably means select. I have no idea. What is a TV? We should look into this. Right, it's mana select. Right. English. Can monitor file scripts that run. Right, allows the program to monitor multiple file scripts, waiting until one or more of them become ready. Okay. So I guess this is just how you use that thing. So we're just looking at doing that basically, right? So now we've got this function that we can just use a while loop for. So effectively, where we do that poll events thing, right? Now, what we want to do is before we do the X11 events, we go, no, udev is more important. So we're just going to do while udev has an event. Then we're going to also do a thing where we say, okay, you know, if our event queue is full, like don't bother filling up the event queue anymore. Instead, what we're going to do is we're going to return back, and then the user is going to poll, is going to read the events off and make more space. So what we're going to do here is we can now receive a device, and this will be a USB device. So strut udev device pointer dev well, it's just that, isn't it? Yep. OS backend udev monitor. There you go. So I think that that's all we need. Let's take a look at anything else that SDL does. As an example, we get action. Right, action for add and remove. Okay, we obviously need that then. And then they unref that thing. Okay, that's all we need. And now we can just plug the rest of our system in. So that'll be that. The action is a string. Everything's a string in this API, I swear. Okay. Get action. So I guess we'll just do a string compare. I already need to make my own sort of string functions, I guess, as if we do a lot of string parsing. Because as we saw, and like string copy functions, because as we saw, like the way they place down the null terminator in such weird ways is just isn't good. So yeah, now we want to basically call our own sort of like we want to have a function which is like OS Linux udev like found device, or like so wait a minute, if it's a device being added, that's one function, but if it's a device being removed, that's another that's a different function entirely. So it's just like udev try add. Oh yeah. And then udev remove, okay? Then we need to unref. Cool. So we're gonna make these two functions. And it's gonna, obviously, this one is gonna use this one is gonna reuse the code we've already written. Udev device. Okay. We need to forward declare. Maybe we'll do try remove, because it won't really remove, won't really add all the time. So let's forward declare that. Strut udev device. There you go. Cool. So let's get these guys in. You want a string type with a start, position, and a length. Yeah, I've already got one of those. But yeah, when we do those string functions, we'll probably make it use that, right? Because I think the idea is, like, when we're not doing OS layer stuff, most strings are going to be, though, it's still going to be null terminated to keep compatibility, but we're going to have a length bundled alongside it a lot of the time. There are some edge cases though where you might not want that. Like as an example, sometimes a hash table is faster if you have a string key and it's just a char pointer versus a pointer and a length, right? No, I think B sharp, what it's saying is if there's a pointer and a length. So a bit like this one. Source core H. Like that, basically, right? Your string is a pointer with a size on it, right? That's all it is. That's what I think he's saying. Yeah. So the benefit is you don't have, to know the length, you don't have to try and find the null terminator. But the issue is it's an extra 8 bytes, and in some cases that is a problem. But in most cases, it's pretty much not an issue. It just, yeah. Like if you got very small strings, sometimes it's not an issue either to use a char star. Right, so let's go and grab that code. So we're going to go into find where we make a new udev thing. So this is where we initialize it. Now we go over all the devices and we make sure if it's a USB hub, we ignore it. Then we enumerate. Yes, we want all of this code. Do we not undef dev? Oh, I don't think we undef dev. That's not good. That'd been a leak, a memory leak. No, it's not that one. Where's dev? Okay, all of this. All of that. So we should undef udev device unref. We need to do that. Right, anyway, we'll take this down to here. Then we want our backend. And then we want to bring that down like that. So that's going to return, because we found a USB hub. Because we found a child USB attached to our USB device, which means it's a hub. So we ignore that. Then we look for a sub input and sound devices. and we get all our device features, which is basically mouse, touchpad, keyboard, gamepad, accelerometer, gyroscope. Then we'll loop over all those devices and try and find some of that. So this is not a continue though. Why didn't that? Oh, it will be a continue actually. Yeah. Get rid of the breakpoint. This needs to go, I think, because it's found outside of that in a different device here instead, with the input thing and not event anymore. And because we did a continue, you need to undo the device regardless, so we need to have a continue thing. Go to continue instead. Basically what for loops do, right? They go to the end, do an increment, and then go. But instead this undefs it. Well, it's kind of a for loop anyway, but yeah. Right, then if there are any features, it's a device. So we add an event for it's connected, and that is going to add, that's going to add it to the pool, right? That's going to add it to the object pool of input devices in the OS. Yeah. So that's good. So should we test? We could probably test this out now. So remove is just going to do nothing. I think it's good to try that out, right? Can we, you know, well, I think we're at a point where it's just, we can just try it. It would not tell us it's been removed though. So, all right. So if I run the game, I think we're stuck in an infinite loop there. Oh, we're waiting on the select event. What is it, E-type? It seemed like it was waiting in select, but then we woke it up. Right? There's something like that. Like I went here and I pressed B. Yeah, it's stuck. It's in select. Like it's just stuck there. Now I don't know. So we have to probably, like, the way the sample code, like this is probably set up for something where it says, wait, this is going to block, right? So we essentially want to do like a non-blocking select. Maybe, I don't know how we do that. Linux select non-block. You have to set an attribute or something, isn't it? There's a way to set it as non. Yeah, this is it. fcntl. You set non-block. Let's try this, yeah. Let's see if that's the problem. So when we do on monitor, we need to get the file descriptor and then do this. Where is that FCNTL thing? File control. Oh, okay, of course it's in this header file, right? Who knew? So I'm just gonna go ahead and do that one. This is not stock anymore, it's the FD, isn't it? So we'll get the monitor FD. Monitor. So when we initialize, we get the current flags. FD flags, FD flags, FD, FD. Just get spaces in here, right? Hey there, egotist. How you doing? How's it going? How you been? Right, we got stuck here again. Is that right? Are we really waiting on that select? Maybe it is. I'm confused. Right, I'm gonna do some printing. Select, start. Yeah, it's blocking. So if I unplug my controller, it's going to change, right? No. So I don't know why it's blocking, and it wakes up when we... It's weird. Doing alright, working on some system inhabitor for, sorry. System idle inhabitor for Wayland. What is that? What does that do? Yeah, things are going good, man. Things are going good. We're just trying to work on hot plugging today. And for the multiple devices. But yeah, things going good. Oh, Akraz, look at that. Oh, they set it to 0, didn't they? Excellent. Thank you so much. Wait, where's your gem? Where's your gem gone? Did you ungem yourself somehow? Oh, it's /VIP, innit? Maybe I didn't do slash instead of bang. Yeah, probably what it was. Right, let's try this one out now. You know, I could just do this, right? The C way. None of that C89 stuff. Right, it did a start, then it did an end. Excellent. So now should we they're non-block thing. We'll get rid of that and see if it still works. Yeah, that's good. So it crashes because we stopped the application from running, right? We put an exit in there. So now we're gonna in the main function, right? So now we're gonna run it. This is where the fun begins. So I'm gonna unplug it, plug it back in. Oh, it crashed. Maybe because it was already connected. Right, we'll try again. This time I'll disconnect it. So I think it's already connected, that's the issue. So we'll run it, connect it. No. So this time we're going to do a GF on it. So something happened where when I left keyboard focus, something was going on. Something fishy. Yeah, so when I changed keyboard focus, it was like been a problem. I don't know why I decided to do that. So that was weird. So I guess we'll do some print logging because it's difficult to try and get understanding the debugger, right? P vendor null product. Why is it all null? What's happening with this device? Yeah, that's the device. So it's unable to get the string name for it right now for some reason. IO is generally harder with new kernels. Why is it harder? What does that mean? What have they done? And hey there, Ryan, how you doing? Is it doing? Should I put that blocking thing back? And let's see if that's the problem, right? Non-block, because it feels like it's blocking in some way. Because I don't know. So if I do this, we get some event coming through, right? Okay. Now if I do that, nothing happens, but I leave. And then it picks it up when the focus changes. And it comes up and says connected. And then it seems like it does it again. So maybe what we don't do is we don't maybe we didn't unref the device. We unref the device. Right, we're gonna do some printing now. Print udev monitor event. Let's try that. I think we can close this now. I'm not looking at these anymore. Right, so plug it in. Does nothing, but I control. Ooh. As I pressed Alt, it decided to do something. So is it blocking in some way? Right. Poll events. Compile that. It's just writing poll events out continuously. I should probably have probably done like a static int or something, right? Just so we see something continuous happening. Hey, Benno Montana. Yeah, yes, coming along. Okay, we did. No, we're going negative. Was it that fast? I don't know what's going on. What's up with my static data? Is it just wrong? Right. Well, I remember my static data not being 0 before. Remember that. Why are we getting this? Because remember we had that problem before, and my static data wasn't 0, and we had to 0 it. I even took it out though. So we set it to 0. It does nothing. Why? What do I do? I/O is to write kernel modules for your device. Huh. Right, I'm not very familiar with that sort of kernel stuff. So why would your proper way to do I/O be to write a kernel module for a device? Because I thought the device, right, to talk to the device directly. Is that what it would be? Okay. As opposed to going through udev or something. I don't know. Um, right, so C static data is not 0. Working on large scale projects, I realize sometimes pilots cube or set variables are not initialized to 0, and sometimes requires a set must be initialized at the start of the program. If you do not initialize them, the compiler will initialize them to 0. So normally, the program damaged the memory. You cannot rely on assertions. So I'm coding your program, set the static variable. Right, so maybe I have a, that could be probable. Maybe something, yeah, but even static memory, like I'm not doing much. So if I do this right, let's do nothing. Let's let's go here and say static in. So there's the first thing that happens. Wait a minute. Right, so that is equal to 0. Yes, something's going on where it's going off the end. So my static data is not 0. That is not good. Oh my days. Yeah, so even in OS initialize, this is happening, right? So if I move it after here, so if I move it after OS initialize, it will just like, oh, it's still 0 for this one there. I'm just gonna stick it out here. What was it doing? It was in initialize or something. Go into graphics in it. See what? I don't know what is buggering it up. Right, it's still 0. But it happened when it was in OS initialize. So I guess it's just luck where it lands in the executable. Yeah, it was weird. Okay. Anyway, so make it start on 1. But yeah, okay, I'll keep an eye out for that. Yeah, I could do a watch point on it, isn't it? We can do a watch and find it, can't we? So stick a breakpoint here. Well, let's not stick a breakpoint there. Let's put that there. And then that'll be, yeah. So I can simply open up and then do a watch I. There we go, boys and girls. Here's the answer. Yes, you need to unarm devices. I still remember DirectX 81 games used to come with dedicated drivers to get better perf. You do an unlock in OS initialized before the stack memory. Yeah. So what is the line that does it? Is it this line or that line? It's in this thread or this function, so it must be this line. Is my oh, it's not big enough, isn't it? That's why. Okay, I know the answer. Right, here's the answer. Basically, we have this thing called like OS Linux, right? I haven't got a surge in there. Damn it. The size of OS Linux is not the size of OS. Wait, OS backend size. Damn it. It's set to 8 bytes. So I didn't have the assertion the whole time. Right. So now it's actually complaining. So what is this? So OS Linux is a backend implementation of the OS structure. This is a global, right? And it has a array here. And we basically cast this array. It's aligned to that alignment and this size. And that's defined for each backend. And obviously, yeah, I need to adjust these. I got an assertion here. I got an assertion so it tracks that rate. So obviously this is far bigger now. So it's 1 pointer. You know, I gotta guess. I gotta So should we do 48? Well, I don't even know, right? Right. Pointer. That's probably 32 bits, and that's another pointer, so that's 3 pointers worth then. So 8, so it's 24, 28, 32, 36, 40, 48, 56. No. I know, right? It would be nice if it told me the size. That'd be handy. It's even hard on like in Visual Studio to do this as well, because you can hover over it and it tells you the wrong answer sometimes. This is the problem with this solution. I can obviously just do this, right? Core abort ZE. No, give me it. Alright, run the app. 64. Dun dun dun. Rightio. So now my memories should be 0, right? Yeah, they start from 0. Right, so now we know this thing increments. Look how fast it is. Look how fast computers are. Whoa. And then... It would be nice if the compiler told... yep. Yeah, that's probably a good shout there, Ransel. Yeah, just ignore that for now. Yeah, so now it's much better. So where we had that problem before with the static, well, it was an array. Anyway, maybe we'll come fix that, but... Oh. Right, so we want to... So we're still trying to figure out, like, so when we plug in the device, it doesn't really... Like, does it get in here? Like, sorry, so we know this is going, right? Or do we? Do we know it's still going when we plug it in? So if I plug this in, do we know it's still going? Yes, right? But only till when I click away. Did we fix the crash or something? No, we didn't fix the crash. Alright, let's try that again. Right, so only till when I... Huh. Only when I did a, like, change the window or something did it bother doing that. Static print. Do you get a static print? Is there a way to do that? I don't know if there is, no. Or wait, or put format arguments into the static assert, yeah. Yeah, the assertion is there to catch the size change. But yeah, I could make it greater than or equal to, couldn't I? And then that'll be easier. So I'm just trying to figure out what happens in my code. Like when we was running this. So should we put a core breakpoint and just see if it hits that, right? Because it might hit it or something. So we run that, it's going to do that, and then we do this. Nothing happens, but I Alt-Tab. And now it doesn't do the same behavior anymore, now that it's printing out, for some reason. So for some reason, if I remove this, right, and then compile it. Oh, okay, wait, let me... Huh. When I alt-tabbed there for a minute, it did this device node stuff. Wait, okay, I think there's other code running. That must be it. There's other code running, right? I alt-tabbed, then it hit the trap. Then it hit the trap. I'm confused. So that device node is stuff that comes from this X11 code, that's X input. But this does absolutely nothing yet. So that's not a problem. So why is it when I add this if state, this in, this thing never gets hit? Captain Price? Who's Captain Price? Individual patch which allows static print. Ah. I know there's a way to do message. You can do message, but yeah, it's not printf though. Like there's a message pragma that you can do. Call of Duty go, fair play. Yeah, I haven't formatted that stuff from X input to, yeah, because I was just getting it to work, that's why. So I just was sort of like just writing code, you know, in a very horrible way. Right, so how is this thing behaving? So how the thing must be behaving is that it is doing this. So it is going over and over and over it. But why? So then there's something to do with this code. So I think what I want to do is like see what are other people's ways of checking to make sure this thing file descriptor has changed. Something like that. So let's recheck the this to make sure we got it all right. So we didn't zero the file descriptors. That is probably the reason why. So because we've not zeroed them, right? I love how like I you know, copied code, but I didn't really copy it. You know? Very smart individual I am. It worked. So when I unplugged it, it did something. Now to plug it back in, it did it eventually. That was eventually. Alright, should we try that again one more time? I was about to give up on it. Plug it in. 1, 2, 3, 4. I did nothing else other than count. Okay, this is good. Right, so I'm glad we got that working. So the next thing to do is actually make sure that it can add the device, right? So the problem, for some reason, oh no, it adds it multiple times. I remember that now, something like that. So let's just see. That's how many years it's been programmed for? About 13 to 14 years. Okay. So I don't know how many times we went in here. That's the question, actually. So we should probably bring back that print statement here. So we'll see how many times does it run through here before it crashes. If it runs through it like, I don't know. Right, so now it runs through it like 5 times. Okay, so that's interesting. So if it tries to add a device, I guess, yeah, we should really just like log stuff regardless sometimes. But right, let's print out vendor and product. Okay, you ready? Right, so it hit it the first time, and that's a success. But then it goes around a second time, and it's like, oh, these are null. But remember, it's the same device for some reason, right? So why is it enumerating round, and like, is it giving us back the same device, or is it giving us back a different one? So what I want to do now is, so I know that now. So I'm going to print out, so it only goes around twice. So we do unref the dev. So we're going to say dev equal p for pointer, and just see what that is. You can query block device events in file system to monitor. I'm not sure what that is. Block device events. And that'll crash. Whereas they're all different. Oh, they're two of the same devices here. Is that right? No, they're different still. Right. So I think what's happening is they might not have that property. Get property dev type, I reckon. So we should look for that property dev type. Dev type. So I reckon prop. I reckon that dev type is not equal to USB device on one of them or something like that. I should plug it in. Yeah, USB device, and then the other one is USB interface. Excellent. So what we want to do is like if, so this is the fix. If dev, well, it's not the fix. There's also, I want to fix the other code, but I wanted to fix this problem first. So we want to get this prop val, and like the prop val has to be, so we're doing our own, since there's no filter, like there is on the, like on the enumerator, we'll do this. Dev type, wait, and this, yep. So it's not equal to 0, we'll continue. No, if it's equal to 0, we do all this. I usually like doing continue in that, but we've got this sort of unref thing here, so I'll just have to use a goto, so we'll just use more of the structured control flow. So, yeah, what's the next thing to do? I might go and pour me another cup of tea, actually. Let me run downstairs and put the kettle on. Alright, I'll be right back. Enjoy the chair. Right, looking big. So yeah, the idea is when we do the remove, oh sorry, the add. I think some of this logic where we get these sort of vendor strings, they shouldn't be null anyway. Sorry, we shouldn't crash if the device says it's null, right? So, why are we crashing if they're null? String, all right. So, question mark. then you probably want to say 0. Then that's going to deref it, right? Which is problematic. Yeah, that's not good. It's not good. So perhaps we should just say, do something like this, right? So you'll say vendor ID equals 0, and you'll also say product ID equals 0. And then we'll just say like, well, if that, and then you'd also move this inside here as well, because if you don't have a product ID string, then you might, you know, vendor ID string, then obviously the product ID string is probably not going to exist either and kind of be useless. And again, we'll do the same thing for this one here. An if statement that'll have protection there. Then kind of we already have this example with the mouse. The mouse doesn't have a vendor string, so we kind of want to have a similar sort of system, right? If the vendor string doesn't come back, like I think we'll have it. We might do like a truth table, or we might do like so we'll probably need like a char pointer at the end of it, maybe. Yeah, because you might be able to. So I think you'll be able to do. So you could do a bunch of if statements, like if this, if that, or you could do a switch. So if vendor is true. No. Because you've always got a case if they're both true or not. So we'll just do like vendor. Product. Did I say project before? No, good. Product. So we'll just do like a little truth table thing, right? I don't know how much more readable this is, but so 0 would mean, so we go 0 to 3. So when vendor is not null, it's going to be the last 2, whereas, right? So this is when vendor's not null, and then it'll be an even number when product is null, right? So basically like product, so this is when they're both null. So if they're both null, then you're just probably going to have an unknown name. So you just say like name equal unknown input device. So you might do like XX. Yep. So we might do this. Vendor ID, product ID. You know, we might, should we just jam it through printf all the time? Maybe. Maybe we'll do that. Right, so there'll be a break afterwards, obviously, right? So next one is when product is true but vendor is false. So when that's the case, we'll just make it do a copy, right, into a local buffer. So that's when product has something but vendor doesn't. The one below is when vendor is true, product isn't. And then the other one is when both of them are true, so you basically get this one here. Ta-da! Then quick tip, select from Oh, no way. Can you do that? Can you do that? Select from the second zero, right? Vertically, and then hit G, Control A. Ooh. So I made these all zero for a minute. Amazing. Amazing. Isn't that amazing? I gotta do that more often now. That's been the shortcut I've been missing. Thank you so much. Unsigned, what's... Oh, the 64s, damn you. Right, and secondly, you've got shadowing. And also, see this shadowing thing? We need to make that, get rid of that compile error, because that's... Ugh. No, sorry, we need to make that compile error. That's what I meant. Right, we'll cast these into like a U16 or whatever. U32 really. Right. Okay, that's a good one. Voila. So that's made it better. So now when we run it, what you'll see is now... Wait a minute. Where's my input devices? They're not showing up as connected anymore. They showed up here, right? Oh, we didn't call the function. We didn't call our try add, did we? Right? So yeah, we never called try add in the initialization code anymore. So that is in udev new. So we're meant to call it here. Ta-da! Right. So now, rather than having null USB device, weird, when I click, oh, that's event dev firing. Okay, because it's on the root window. Okay, sorry, not event dev. That's X input 2 firing. Yeah, so this used to be null here, null USB optical mouse, because that's just the USB optical mouse is just the product string, but it didn't have a vendor string for some reason. So yeah, we've just done it that way now. But yeah, that's much better. Cool, so now we should be able to plug in the device and it should be picked up on. It just connected there still, but it's good. Features 2.0. That's not good. Features 2.0. It should be like 3C, right? Features 2.0 is like you've only found one device. You've only found the gyroscope. That's not good. Right, I'm just gonna go quickly pour my tea because the kettle's probably boiled now. Yeah, it's fine. It needs to be downcasted because it's a U16. The vendor IDs and that, I won't go over that. But I'm just gonna get the teas. Right, welcome back. So I think I got an idea of what's going on. So basically, the monitor API is too good, right? So it's only picking up the gyroscope when we plug the device in, but when we make it search at boot, it's fine. So what the problem is I think the gyroscope is anything that's picked up on because the device, as it's called, the device node, which is the event file descriptors, they're not properly ready at the point we search at. That's just my guess. Make sure the music's still going. Still got the music going. That is good. So, that's a bit of a bugger. You know, it's so if we connect it and it's only got gyro, like we can't tell the device what it's supposed to have. Because I'm sure if we do a sleep hit. All right, let's do a sleep 1. This is how we can check. So we do a sleep 1. It's going to hang for another whole second, and then it will take a look. So if we run the game, plug the gamepad in, and then eventually, it might take many seconds because it might be going over many devices. There we go. And then it says 3C here, right? It said 3C there, and that's the one I was looking for in the features, right? See? So this is what we're looking for, but the computer's just too fast, right? So I think I had this problem with events before. Like I think if you wait for write events, you get an event back sometimes when it's written. You get an event back when it's written, and not written the whole thing, right? So you get it in. So the issue is with this, when we plug in the device, it might not all be connected yet. So we could purposely. So the problem is we don't want to. The problem is we don't want to block reading this stuff here, right? So I think if you look at the SDL source code, they do stuff differently. They grab it at the event level and not the USB device level. As we grab ours at the USB device level, so we can traverse the tree and everything. So when you connect a device, I think it's probably safe to say we can give it a second to connect everything, and then we look at it. So I guess what we might want to do is stick it on like an internal queue of some kind, and then sort of go over it and like. I'm not, have like a timestamp, but we don't really have timestamps right now, or a way to do them easily. We'll have to chuck that in. But yeah, this is a problem. Is there a way to wait for the device to be ready in some way? Wait, not the SDL one. Where's okay. Is there a status check? Tags. Date remove. Right, what else on the device can we look at? Get is initialized. It's going to say it's initialized though, isn't it? Right? So we say core assert is initialized dev, blah, 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 blah. Is that something that will fail? So I just plugged it in. It connected it with no problem. No crashing. So is initialized is not going to. check that we can do. This is interesting. Get usec since initialized. So you can call this a timestamp, right? So usec would be like, is that nanoseconds or microseconds? I think it might be micro. Yeah, there's T use. Maybe it's nano. Because TV. Yeah, that's the nanoseconds, isn't it? Oh, microseconds. In time eval. Okay, yeah, it is microseconds. Good. So you can get the microseconds since it's been initialized. So the problem is we don't want to stall. Right? We don't want to stall this event thing. But then when you receive a device, you take it. Right? So is there a way to peak? Basically, can you peak? You could also look at when you get an event, process it a second later. But then for a connection, you probably want to do different to a remove, right? I can't see anything sensible here. Is there a way to make... No. Device is not fully connected, right? Device been plugged in, not seen by... Not what we want. See, if I monitored for input, maybe that's what we do, right? We get its pet. Oh. Right, so the other way of doing it is look for sound and input devices and then get their parent, which would be... The problem is when you do get parent with subsystem dev type. Oh, interesting. Right. Yes. So maybe what we do... Alright, I've got a workaround. So instead what we want to do is we'll monitor and we'll wait for input and sound devices. Those will come through, okay, through the monitor. And then that would mean obviously more of them have been connected at that point in time. And then what we can do there at that point is go, okay, can I get your parent with a subsystem whatever, right? And then this should be the USB device. So we'll say USB dev. Now I don't think you need to unref. Okay. So we pass in our device. The subsystem is USB. And then we want the USB device dev type. So let's try that. So this should be, so we get the action, and then if so, pass in the USB device. And then so we should be able to get rid of that. And that. So let's try this one. So hopefully that will be a way of avoiding having to stick it in a temporary array or something. So we plug it in. Right. We got many connecting that time. Right? So it connected it once, gave us an... So obviously we've got a bit of a problem as well, is that we, so maybe this is a good approach. We can keep connecting feature, all right. Here's what we're going to do is when you connect the device, if it's already connected and it we just merge the features in, right? If it comes in again, I think that's a good, so yeah, this can work. And we can merge the existing data in. I think that's how we'll do it. The only issue is though, you're enumerating, you don't. I think we might have to have a separate function. This function here is great for when you start up the game, but I think we want to split it. Do we want to split it into two? So maybe this. So we get the feature, and maybe we'll have like a. See, my problem with this approach. No, yeah, okay. My problem with this approach is the event connected will fire. With an incomplete set of features. So the first time you look at it, you'd be like, oh, I've got this thing connected, it's just a gyro. But really you want this one. And obviously this comes through in the same, probably in the same loop anyway. I don't know, maybe it doesn't. So that's problematic. So yeah, we can't really, unfortunately that approach is not good. So that leads me to the one that we basically come up with before, which is we just need to check this, right? So the only sort of things we have is the only thing that we have is dynamic arrays, and we don't have a queue. So what this means, so people are not going to really be hot plugging devices, right? A whole load. So I'm hoping we can fill up a stack, and then we should be able to just go through the whole thing. If we manage to go through the whole thing, we can then clear it. Although I really... It would be nice if we can get the number of devices at a point in time. We can be like, oh, we received this at this time. Wait a second. Now process that many events, then check it again. Or we could just enumerate the whole thing every time. No, that's problematic still. Right, we need to check when someone's been fully connected. This is where a queue, like a queue data structure, is probably perfect, because you would check the top of the queue, look at the device, has it been a second since it was added? Right, we might do an should we do a queue data structure then? You know what? I can't. We're just gonna do a temporary one because a more general one would be too much time. So we're gonna add. This is horrible, right? OS Linux udev device found or like added. So you want to get the device, get your dev, and then we want to have a little. We don't really care about. No, actually. Yeah, no, we'll have to wrap it in there. So we'll do a core define stack. And we'll do a circular buffer, but we'll manually do it with a stack. So core stack, this thing. Devices. Added devices. Queued. Added devices. And then we'll have a queued head index and a tail index or something like that. So we'll just do a manual thing for it. So what do we want to do? So I guess we'll have like a capacity on it. Udev devices added. Capacity, we'll just stick that at like 256 or something. Hopefully we never fill that up. Maybe we could do more. So when we initialize the monitor, we'll stick that in there. You know, if we fill it up, we can just tell it not to take any more in, right? So basically, we'll just initialize that, right? So it's a core stack. Initialize, take the address of that. Oh, wait a minute. OS backend. That one. We need to pass in the custom allocator. We'll use the static allocator for that. Huh. Right, let's get the static allocator. Let's chuck it up here. Where is that defined? Game.h, okay. Too many of these files open. Right. Include game.h. Okay. Awesome. So just hop down, initialize this. Nice. So now that's going to get initialized. So what we want to do is when we add the device, where is it? Oh wait, we want to resize it to be fully, we could have just done a bit, I don't know why. We do get bounds checking. I don't know why I did a stack though. Yeah, let's not do a stack, it's a waste. Let's just do a manual queue like this. So we use our core allocate an array for me please of t. So t is this device added thing with a static allocator of that size or that many elements. Excellent. So now just allocate that. So what we want to do is when we have our monitor, okay, this one. So we kind of want to like not come into here if the see, I'm not sure why we're returning here. This is not good. Oh yeah, sorry, the event's full. That's fine. So we want to know like if the OS backend queue head index. So like how do we know if this thing is full? So that if the head and tail point to the same place, the queue is empty, right? If do I have to go back and find or I could just do it a different way. Yeah, let's not do head tail. Let's just do like, let's do it a bit differently. Let's do a count instead. Okay, so if the count is equal to the capacity, this one. Yep, so if it's equal to the capacity, then the queue is full. And we just want to like not take any more events off this thing. Great. So we receive a device event now. So rather than processing it, well, okay. We try and process it. And then if we get into this add section, we're going to be like, okay, hold on for a minute. Find the insert position, which is the tail, right? So we'll do like insert index, which would be like a wrapped thing. So it'd be like this plus another version of it. So that head plus that, then wrapped around OS Linux cap. Okay, so that wraps it in, keeps it inside the queue. Hey Octo Chris, how you doing? Yeah, I'm doing good, man. Just dealing with problems that come out of nowhere when using operating system things. So we currently found out when we plug in our USB device, it's not fully initialized when the event system from the OS picks it up. So we're currently sticking it in a queue, and then we're going to process it later, but we don't want to block our event processing loop. So that's why we're sticking it in a temporary queue. So yeah, there's just a whole lot of can of worms. My name is Chris and I like game dev. Wait, has it just been a while since I've been here? Um, I'm not sure. I'm not sure. Have you changed your name? Hey there, Lee Mean Gene. How you doing? Can you guys access GitHub? Let's have a look. Apparently it's fine on my connection. No, it doesn't say you're new. GitHub appears to be working for me. So you'll be like, yeah, so you would basically say OS backend, queue devices, insert index, equal. See, I don't know why I needed to wrap it now. I've wrapped it in this type, but it's kind of not needed. Pointer to the pointer. My favorite. So we'll just say dev, right? That's the USB device. Yes. Strut udev device star. Did I get that right? Okay. Okay, so chuck that in the queue. Nice. Now we process the queue, right? So while it has events, right? Sorry, it has the stuff in the queue. And then we get to use this lovely function where we get to have the nanoseconds since it's been connected. So we get the device from the head of the queue, right? So we get the device from the head of the queue. So strut udev device star dev equal that. And we get to use this nice function called udev device usex since initialized. So we can tell how many microseconds, right? So microseconds is obviously 1,000 times more nanoseconds, but it's like 1,000,000 times off a second, right? Because it goes nano, micro, milli, and then seconds. So, hey there, TCAP, thank you for the raid, appreciate it. Welcome, welcome. How you doing? How's the stream go? Mr. Joe Mega, good to see you. Hey there, TCAP, thank you, sir. Thank you, sir. Welcome, Raiders. So we're currently working on adding input device, multiple input device support for Linux for our game without an engine. Run a game from scratch in C, no engine. Doing it all from scratch. We've got a custom GPU abstraction that sits on top of Vulkan. That's compute only. We're going to use that for 3D graphics later. We're just doing some core engine bits and bobs, like getting controllers working from nothing but the OS, which is basically rocket science. I would say rather. But yeah, that's what we're doing right now. But so we've got the devices being picked up. We're trying to do hot plugging support, and turns out when you plug the bugger in, the device isn't fully set up yet. So we're putting it in a temporary queue. They're going to process it a second later, but we don't want to block our main event queue and blah blah blah. So this is what we're dealing with right now. But yeah, Linux. How we all doing? Oh, picoseconds. Give me those picoseconds. Nano is a billionth from a second, I think. Yeah, and then a micro is a million. Yeah. And we're at microseconds right now, U6. Right. But yeah. If anyone has any questions about the project, feel free to ask away. We also have our own little custom C compiler that we use to write shader code. So we can write our shader code in C and share structures, functions, and all the maths functions, right? All that good business. Right, can I get this right? So yeah, we just say if. So it gives us an unsigned long, right? For some reason, long int, good one. That better just be 64 bits. So basically, what we're saying is if that is greater than 0, right? So a million. So 1, 2, 3, 1, 2, 3. It's a million. So if being connected for 1 second, right? Fingers crossed that works. Then we do the device add. So this is meant to be the fix, but if we process that here, if has not been connected for 1 second, we're then gonna just break. And this one is going to say, oh, we've processed that element. So we're going to advance the head by 1. And then we're going to advance the head by 1, but also make sure you wrap it. Wrap it around the cap. Oh, why did I and it? That's got to be power of 2, but the compiler can do that for me. Also, that'd be and minus 1 of the cap, but yeah. Right, okay, there we go. What else? Try add. Yeah, we need to take away 1 from the count. And voila. That should do it. What is this femtoseconds, Jamega? Femto is 10 to negative 50. Right, so that's... So nano is a billion. Pico, then femto. Fair enough. That's tiny. In a single picosecond, light travels about 1/3 of a millimeter. That's insane. Right, so now my thing is wrong because we've added 2 more pointers, right? So I've got to change the back end size. 2 more pointers, that will be 80, right? Wait, no, 72, 80, yeah. Compile. Right, fingers crossed this works, right? So we're going to unplug the PlayStation 5 controller. Going to run it. And I'm going to plug the bugger back in. 1 second later. Come on. Device connected. Oh no, I just moved my mouse. What is going on? Okay. Did we not increase the count? Was that the problem? We got the insert index, but we didn't increase the count. All right, so it already takes like a second anyway, but then we've added another second, I think. Yeah, so it takes like a few seconds. All right, so ready, connect. Wow, something happened. So it's saying receive device. Oh wait, get. Right, so the interesting thing is we didn't. Oh, it didn't unref, but we stored it in here. So the interesting thing is you need to continue to skip the unref on that. I think that's right. So we plug it in. Oh ho ho! It worked. It worked. Right, so we plugged in the controller. Sony controller's plugged in, and then see this features 3C thing. That means all the features are enabled, right? That we want. So we've got 3C. So that is touchpad, gamepad, accelerometer, and gyroscope. So yeah, touchpad. Woo! This thing. In case you're wondering about that cesium, the cesium, right? Hey there, Danzy, how you doing? Gonna get kids' bedtime routine underway. Be back later. Awesome. Thank you for chilling out. I'll yeah, hopefully see you after you've sorted the kids out. That's gonna be me soon. Sorting the kids out for bed, reading them like a story or something. Cesium. Right. Right. Resist 0, how's it going? You better be resisting. Right, the cesium standard is a frequency standard which photon absorption by transitions between the hyperfine ground states of cesium negative 133 atoms. I'm not sure what that means. Is to control the alpha. The first cesium clock was built. Right, so it's like at the atom level, is it, basically? Atom clocks are one of the most accurate time and frequency standards. Okay, atomic clocks. That's the thing we use to define a second, right? I thought the way you define a second is you go and 1, and 2, and 3, you know? Everyone's got it built in. You don't need one of these clocks. What are you talking about? That's pretty precise by my standards, you know. Right, so completed it, mate. That's what we've done, but we haven't. So we've done the add, but we've not done. Yes, it 1 Mississippi, 2 Mississippi. That's as atomic as you can get it, you know. So we haven't done the remove. And we haven't also solved the problem of like what happens when you try and add multiple of the same devices. What do you do? So we'll start with a remove because this is going to fall under the same sort of thing, right? Because it'll just add 2 of the same controller, and that is not good. So the remove is going to enable us to map, right, a device. So the thing is we don't have any internal operating system stuff in here. So we went and sort of like got some of where is it? So we got all these things, right? And these need to kind of go and like these dev nodes kind of need to be embedded in with the embedded in with the, where's the OS internals? Input device. They kind of need to go into here, right? We need like one of those back end things. So we need to like get a input device. We need something like this. So we can have like an internal thing. So we can put like the udev device in here. We can stick all of the event node strings, you know, all that good stuff. So when we create that event, or we queue this event or whatever, we're not going to get back a device ID. From when it's connected, right? We're not going to get back a OS input device ID. So we'll sort that one out. So, you know, we got it here. So it'll create the device. Really, it should deduplicate and, well, no, see, it just adds it. So I think it should be up to the back end to see if it's already been added or not. But maybe we can have like a user key. No. Alright. We're gonna pass in, we'll return a pointer instead. So the back end can fill it in with all the stuff, I think. But what we want to do, so we'll return the device, but sort of like, I think we need like a hash table, right? So we'll need like, along with the object pool, I think we'll need like a hash table. Luckily we got one. So the hash table is going to link, it's going to map some form of like pointer. Does it need to be a hash table? Like, hash table is probably overkill considering you're not going to have more than like so many. Hash table is overkill. So we'll have like a key, which can probably just be a pointer. I'm not sure. Yeah, we'll make it a pointer, or like a U64 or something. So the idea is you'll have like a input device entry, something like that. And I think it's probably best that we just have like a U64 key, and it just maps to a OS input device. So you could use device num on Linux anyway. It doesn't have to be U64. But U64 is probably fine. Device ID. So we just basically do a lookup and get the device. And we'll be using this for remove and for adding and removing. So I think we use a stack, right? So do one of those call define stacks. Call define stack t. And we'll have a bunch of entries in here, so you can just do a lookup and get that thing. So it takes 9 billion and whatever transition to have 1 second. I'm not sure exactly what that means. Hey there, Laurie Master. A cesium clock is basically a radioactive boy that throws a tantrum every X amount of time. Oh no. Yeah. So basically, like the arm is connected to the desk. So what I really need to do is I need to get one that touches to the wall. Um, but yeah, just got to yeah. Um, yeah, maybe I should invest in one of those. Maybe when I take the week off for when the baby comes, I'll have a think about that. Upgrade the setup a bit. Vibration isolation things. What sort of things are you thinking? Because I don't know what that. Oh, put like a bit of rubber underneath my keyboard, maybe. Yeah, I don't know what that help. I don't know. Maybe. Um, right. So we want to like scan this. So I guess you want the ability to say backend find input device with a given key. So it's kind of like it's kind of belongs in the input device section, really. So there's an input device find. You know, we could have done OS backend maybe, but okay. It would have been better if we said OS backend, but I guess this is fine. Maybe not. So we're going to say find with a given key, and it gives you back a device ID. So you do the find. If you can't find it, you can just add it on. But this is the thing we'll use for removes as well, something like this. So the way we do it. So let's go and implement this guy first. You know, it's just a for loop, right? We're not, you know, it's not rocket science. As I was saying, there's not going to be many entries. So compared to a hash table, this is probably better than a hash table because there's just going to be a handful of entries. The issue, oh no, there's not an issue with it because you can just do a swap remove when you remove it. Yeah, it should be safe. So basically, what you want to do is say for we've got a for range macro, index 0 or core stack count GOS entries, and then we're just going to index into the entries. And then we say if, so I guess we'll pull that pointer out. You know, maybe we can put that in the section up here. Get us a pointer to the entry. If the entry is key, then we can return the device ID. So that'll be entry device. If not, we're going to return the null one. Right, so it's core ID null. Then we've got to do OS input ID. Like that. Voila. So I need to take the address. Otherwise it cries. I need to take the address. If not, it cries. Right, so there's a nice function we can just reuse in a couple of places. Ta-da! So what do we do now? So when we do a sort of connected device, what we kind of want to do is say, right, do a find. So we need like a key to come in. Use 64 key. And the key is going to go into here. And so if the device is already connected, so not equal to null, what do we want to do here? Do we want to just like return null, I think? Yeah, so just don't do anything. Let's do that. Well, it depends on what mic you have, right? Yeah. A good sturdy desk. This is a IKEA desk, my friend. The problem is the arm is a low quality arm. It's very flimsy. So I think that's part of the issue. It's a flimsy. I think I think yeah, it's not a good. It was cheap. I know, right? Can you believe those developers? Developers. Um, right. Let me open this up in incognito. Yeah, I've already got one of these. Have the things come off? No, I've already got one of these. You can. I don't want to move my mic because it will make a sound. Yeah, all the things are attached. But yeah. Hmm. Yeah, I have a bit of a play with it. Okay. So if it's disconnected, the thing is like you need to do that find. So we could give you the entry pointer back. Right, so we give you. So if we do a find. We never really want the entry unless, or the index to the entry, do we? Unless we're trying to actually disconnect it itself. Right, so really, in that case, we can just take this. So this would be like a find. So you get the entry. This would be like an entry index. Entry index equal. You know, it must be in there, right? But I guess we can do like a E32 max, right? So you're passing your key. So how do we have the device ID? We didn't have the device ID, did we? So we'll pass in a key. And then if the entry index, because you know the operating system can give us anything, and then this would mean that we're safe against that. Now we can then use we get our entry now. And then we can say entry, device ID, remove it from the pool. And then we can do our swap remove, which would be our core stack swap remove, which does a quick remove, right? So if you have an array of elements, we have an index into there, rather than, all right, drawing time. You have an array of elements. Okay. So if you want to remove this element, you typically would have to copy all of these and shift them to the left by one. So they go like that, right? So you use like a mem move. But then, you know, if you have a really big array, it kind of sucks. So if you don't care about the order, you can do a mem swap, which basically says, hey, take the last element, copy it there, and then shrink the array by one. And then that's a swap remove. So swap remove based on GOS input device entries. Swap remove entry index for me, please. There you go. So that should be all that we need. So we need a key to come in here. U64 key, U64 key. So now we get to plug that new one in. So the problem is you wouldn't actually you wouldn't have been able to deinitialize, or sorry, to get rid of anything, right? Which is problematic. So what you probably want is a way to pass in the entry pointer. Okay, so perhaps what might be good is you have a find and you have a find entry. Okay, because the OSs will want to, the backends will want to use find entry. Yeah, I think that's true. So this will be entry, that'll be null. And then we can use that to get the index by just doing a pointer difference. So then really what we can do is we can just do this instead. So the entry comes in here. Because that has both the key. Wait, do we care about the key? I don't know if we actually care about the key. Although it would mean we're wanting you to give us the entry, so it will make you use find entry instead. Yeah. So it's good for more as a documentation, as a usage sort of thing anyway. So we can get the entry index by doing a pointer difference between entry and that dot data. Then we just delete all that. Got the entry already. And voila. So you could just go update that. Cool. Right, let me just switch the light on because I'm probably invisible right now. Yes. It's so strange that so much movement transfers to the mic. Yeah. Maybe I can up my levels and give it a listen, because weird. Right, so if I do that, I can hear myself more. It does rumble, right? Let me up it even more. Okay, I'm hearing myself really loud now. I hear myself breathe. Yeah, it does vibrate, doesn't it? A little bit. It's very subtle though. Yeah, like. What is the point of swapping if you're going to shrink by one? Instead, right? Cheers. Right, let's look at this. What's fixed? 3 copies instead of 1. If you just copy the last element by index. Yeah, that's what the swap remove does, right? Right? The whole point of the swap remove is you're doing... That's the whole point. If you're going to be shrinking by 1, 3 copies instead of... Yeah, so the swap avoids you doing 3 copies, right? Depends on where you copy from. Or you remove from. If I remove from this index here... Oh, yeah, sorry, it doesn't technically swap anything. Yeah, hey there, VMT. Doing good, thanks. Yeah, you like, copy that one over it. Yeah, good point. Yeah, maybe it could be called a replace remove. I don't know, or pop I don't know. Maybe think of a better name for it. Yeah, you're technically just going whoop. And then you're reducing the count by 1, making this smaller. Copy and pop. Yeah, copy and pop remove. Sounds like a drink. Unordered remove. Yeah, see, I call it shift remove for the other one, but I don't know. Think about that. Right, what's this fix? And how's it going, VMT? How's things been? Fix freezing without input. Oh my days, wait. And also hook up SDL joystick. ES freezing without input. So we had to wait for a second, didn't we, when we did ours? What is this? User event. Delay 1 second. This doesn't need to be accurate. Oh, I seem to have the same fix. Or does SDL have the same This sits on top of SDL. Okay, so this emulation station seems to sleep for 1 second to wait for the input devices to come in. And are they... I'm not sure exactly what they're using, but yeah, they might be using... Yeah, huh. But they're using SDL. So maybe SDL has the same problem. That's weird. Maybe they fix that eventually. Weird. How did you find that? It was a good find. Yeah, so we're doing the remove now, aren't we? So to remove, we want to use the find entry API. Wait. Device connected. We're going to sort this one out. We need a key. What's the key? So the key is going to be... Just get this device. Device. Input device. So it's dev, isn't it? That's the key. So we cast that to a U64 from a pointer. And we say, okay, if the device got added, now we're going to fill in all the bits and bobs for our device. So we need to go into the internals and, or the proper internals and, sorry, the Linux internals. Where are my Linux internals? And my Linux internals need OS Linux input device. And this is going to have the udev in it, right? So we're going to have the strut. Do we need a udev device? Like, that gets a reference. When do you ever need the udev again? Like, you've used udev to solely get, like, it could be the key, right? It's the key. But you don't need the key. I don't think it'll be the key anymore. We need to find something that's unique about it. There is a device number for it. We can use that. Yeah, so we can use that. What other things were there? There's like basically these things, right? This mouse dev node thing, so we can actually process the events. Yeah, these need to be in there. And then we need to stick a sort of like an assert to make sure the structure size is actually that. So this is 6 pointers worth. So 6 times 8, do some maths. Is that 48 or something? Oh yeah, maths. So we can now fill these in. So when the device has been connected, we can then say input device, these things. Ah, Silvercore, welcome, welcome. Remove and fragment. Oh yeah. I like my memory fragmented, thank you very much. Things look great, my new workstation is quite nice. Can virtualize the kingdom come. Oh yeah. Yandex rocks, easy to find. Isn't Yandex that Russian company? But what, you use that to search for stuff? Thank you for your info, comrade. Yep. Well, not using Google isn't taking the info, but yeah, all search engines like that anyway. Yeah, Google like used to have good results, but now it's pretty bad. And then like GitHub searching is like, hey, we're gonna say we've given you all the results, but really we're just gonna give you a handful, like including searching through repos. It's really bad. Right, so we should be able to go device, then we're gonna do, wait, we're gonna cast it into a backend. So we need a thing for that. Input device, take. See, I don't know how much we need to do this, but we'll see, right? You have, no, it'll have to happen twice. So we'll have a function for it. Basically, obviously, we just cast that array of data into the type. Array of bytes into the type, right? Backend data. Oh yeah. Cool. So now in, oh my days, there's too many things to remember. All right, down here. There we go. So I want to get the backend version of this. Get the backend. Linux input device. Pass in the input device. Get yourself the backend. And voila. Cool. So now I set those things. I don't know how long they're going to live though. Lifetimes and things. We'll fix this as this goes, right? Okay. That's good. So now let's do a removal. We need to use that new nice function, which is going to get us a nice input entry. And that will be a OS input find entry with a key. Oh yeah, we didn't do a key, did we? Right, so we've got to look for udev again. There's a dev number, dev t. I don't know what dev t is. Dev t is __ dev t. Okay, and dev t is __ dev t type, and then that is equal to quad type then that is equal to, finally, a 64-bit integer. Right, then we got all the type defs. My days. If I didn't have an LSP there, that would have been annoying. Or didn't have a text editor integration on that, would have been crazy. So we'll use dev_num_t. So dev or dev_t key equal udev device get dev_num dev, and then key we're going to here like so. That should cast auto magically, and then when we're here we'll get dev_num. That'll be our key that we throw in, get our entry. If there's an entry, we'll get the device, and then we'll get the backend. OS input device get entry device ID, get the backend for it. Now we should deinitialize things here, right? And then afterwards we call OS event queue input device disconnected, pass in the entry, and voila. Oh no, I'll just leave stuff in between that. Right. Cool. Let's get that compiled and see how well we did. Apparently there's no one of these. But I could have swore I put one of those in there. It's just this entry. Find entry, that one. See, that was C++. Bit hard to find that. Oh. Yeah. Yeah, the internet's just like filled with tracking stuff, isn't it? That's why I try to use the Brave browser, and try to do the best job there, hopefully. Did you check what happens to the device when the device gets connected and disconnected in a short time? I haven't tested that yet, because we haven't got to the point where we do the disconnecting yet, but that'll be something we can check in a second. We've just written the disconnect code. It shouldn't be a problem, because what happens is because we wait, like the device takes a second to connect, and then we need to make it wait for a second to make it be fully connected, because it's partially connected when the monitor API picks up on it. So we put in a temporary queue, then we dequeue it. Yandex code is pretty nice also. Oh, sorry, u.com/code, okay. Yeah, but people say DuckDuckGo is good for privacy, but then it's a privately owned company. So it's like, they just tell you, they just say to you, right, that it's good, right? Is there any proof of that? There's also some of those open source ways of, you can run your own sort of like server that sort of gets all the search engine results from other search engines, and then like you can use that or something. Right, so the device is already connected. You can see it in the background. There's like a Sony device. So if I unplug it, nothing. Bugger. Right, and then it got connected again. Great. So that shouldn't have happened unless the it's getting disconnected, but it's just not telling us. Yeah, it connected twice. Because I swear I'll recode for that. So we're going to put breakpoints in. We love ourselves a good breakpoint. Core breakpoint. So we'll hit a trap. Right, Akbar in the house. Secret trap here. So, entry. It didn't have an entry for the key, so the dev num was different. Oh, for the whole point. Wait. Something's fishy. So we'll do a thing. Key. Right. I'm gonna put the vendor in. Vendor. I know I spelled it wrong. It doesn't matter. Key LU, and then vendor key. Then we'll just do the key here because we can just do the check. Okay. Right, I'm going to connect that device. We got key there 48425. Disconnect. 48425. So clearly my my entry table is just a bit silly. Wait, did we not? We didn't push the entry on, did we? That's why. We didn't push the entry. So basically the issue is me not completing the code. So we happily did the... Why is there so many files open? So we do this find and bail, but we don't actually insert it right. So after you've got all of that, we need to do a OS input device entry equal core stack push. Take the address of gos.input device entries. So we push on one entry, and then we just set the device ID to device ID, and obviously key to key. And that was the missing link. So I guess we'll leave it in connected first time. This time. So it's going to start connected. Oh. Stack is not initialized yet. Sort that one out. Stack init. Input devices entries. Right. That would help. Right, so start that up. Now we're gonna disconnect. Disconnected. That looks really good because got all our... the problem is the name just says is empty. So obviously we've got there's something fishy with that. Wait, that shouldn't be empty, right? Oh no, we gave you a pointer to some memory that got zeroed or something. Yeah. All right, then we plug it in, and there you go. It comes up. Ta-da! Disconnect. Good. Plug it back in. Right, and this will work for keyboard and mice. You know, I could plug in more things. But that's really good. Where's my terrible... Here it is. A terrible mouse, which got buggered somehow. I stopped using it and then it got mistreated. It got like put in a place and it got destroyed. Which is a shame. So I'm going to plug this device in instead. And we should see a mouse pop up, maybe a Logitech. So Sony controller disconnected. Logitech mouse connected. There we go. Oh wait, sorry, Corsair. Corsair Gaming. So obviously, the vendor ID is Corsair, and the product is Corsair Gaming Saber RGB mouse. And that's just got the mouse capability because you see the features down at the bottom. It says one. That's the mouse. So then we disconnect it. Yep. And then obviously it'll connect again. Look at that. The code works. Right. This is good. Can you reduce the delay when it plugs in? So we wait a second, right? Currently. Should we try half a second? Yeah, that's a good point. Well, why don't we see where the breaking point is? But to be honest, we don't want to rely on it for my computer being like, oh, the breaking point is or the boundary is like maybe it's like at 200 microseconds or something on my computer, but what would it be like on a slow computer? So there's that to take into account. But yeah, we'll give it a go. So let's move it. Let's drop it by. Let's drop it by. Let's take it to 1 millisecond, right, and just see what happens. That's a lot of time still, right? 1 millisecond. Yeah, I did just sleep to try it out, but I didn't want to settle on that one. Like in my main event polling loop, I don't want to do that. Yeah, that's still not good enough. Can you see that 2-0? That's only picking up the gyro. So 1 millisecond is not fast enough. Should we try 10 milliseconds? What's the problem? Why do you have the delay there? So the problem is the device. So the monitor API is too good, right? The when we do this udev has event, right, and we do this sort of like receive using the monitor API, receive the device that's been connected. So when the USB device gets connected, the children devices, which this breaks down into, right? So there's an event device which has the device node for the /dev/input/event number, whatever, for button presses and the analog stick in one. The touchpad is another device, and the accelerometer is another device as well. None of those are initialized right away. So what happens is if it's an add event, we need to put it in a queue. And basically we look at the queue later on and we process it from obviously the front. So we push it on the back and then we process it from the front of the queue. And we check to see how long it's been initialized for until we actually can take off the front of the queue. And then we add it properly. Oh, is there bind? Huh. Right, I'll move it down to like one microsecond and we'll see if that works. Right, I'll plug it in now. Damn it, it worked. What? What is this bind thing? Man, thank you so much. I would never have found that. That's insane. I should have read more docs, clearly. Because I looked at 2 samples. I looked at one on GitHub, and I also looked at SDL's one. They both used add and remove. Right. Okay. So we want bind. We could do unbind as well. Let's do that one. Right. So then we don't need the queue anymore. So I'm glad we didn't go and implement a whole queue abstraction. Right. Turns out you don't need queues. Queues are they're never needed in code, right? Because you just do it right and then you don't need it. But anyway, I'm glad I thought of at least a quick way of doing the queue. So we should just be able to do this. Let's remove the evidence. Ah, fair play. Yeah, I've seen that around. Wait, remove 2 pointers, wasn't it? Is that right? So is it 64? Yeah, good. Right, let's try that now. Plug it in. Oh yeah, look at that. So the features we got, okay, is all of the features on. That's good. Damn good. So good. Right. Amazing. Even better now. So what is left to do? So when we remove the device, the string is wrong, right? So the problem with that, so we could make this event structure big. So the problem is the device. So, you know, the best thing about the device is it has a nice little local bit of memory where it keeps the name in there, but when you deallocate it, it zeroes the memory. So the next time this thing is used, it's zeroed memory and it's initialized. So the problem is when we give the pointer back to this. So we could move the buffer, copy the buffer over. Into the event structure. But then that will make the event big. But maybe it doesn't matter. Kind of does. Like, I don't know what else I would do really. Maybe you could like delete it later. Like you can delete the device a little bit later, and then you can keep the memory around. Does the name matter when you remove, or you might want to log it, right? Yeah, see that's the question, isn't it? It's like you don't really need it only for logging purposes. I've disconnected this device. But maybe we can put the logging in earlier. Yeah. Okay. I think what I'll do for now. Now I was going to say remove it, but it's handy. It's handy being able to say, "Oh, this thing connected," right? Let's. And it's kind of this printing code is like, you know, I probably want to bring this internal into the OS section, but it's going to like this printing code is going to work off of the event type, but then you don't want every event to be logged like mouse movement because that'll go absolutely crazy and your logs will be filled with noise. So Maybe what we will probably do instead is actually put this code inside the OS internals, and yeah, I think we'll roll with that. And not put the name in the event. So we'll take the name out, and what we'll do instead is we should really have like a logging API somewhere. We haven't got that yet. So we can control these logs a little bit better. Maybe that's something we can work on after we've got the after we've got it working for Windows. Maybe we can work on that, or maybe while we work on it for Windows, because I don't think on Windows we have printf working because it's a GUI application, you know. So I think we'll probably have to do a logging thing actually. So maybe we can do that when we start Windows at least. Just do a quick logging API. And we can have different systems. We can log out to files and stuff like that. Because it would be good to have some logging, especially when you connect devices you don't know about, you know. So this should go in the OS section when you queue an event. So if you connect a device, name.data, vendor ID, product ID, features. Okay, so take that, chuck it in the thing here as well. So what's missing about the other one? Okay, so we apparently haven't included standard IO yet. Right, name is not there anymore. Name is not there. Good. And then we'll just entry. Wait, that's just device, isn't it? Device, device, device. Excellent. So that'll be that'll be a fix. You know, it's not. Those printf errors are so good, but the problem with printf is it's kind of terrible because there's no standard U64. There's no standard U64 print format thing. You have to do either do a custom printf for that. Right, so we connected the device. Right, it showed up twice because we got two different prints. Then we disconnect it. Excellent, it works. Cool. Good job, folks. Look at that. So that's hot plugging completed. So the next thing to take a look at would probably be hey then, Nico, how you doing? Good to see you. How you been? So next thing on the list is to probably do like events like these guys, because we used to have them working right, mouse and keyboard, but we didn't have the multi-keyboard working. But now we've been using X input 2. So we figured out using X input 2, basically we can list all our X input. So we figured out we can open these event device node file descriptor things directly. So we had to use X11. Then we tried X keyboard, that didn't work. Then we tried X input, and that seemed to work. And basically what we can do, see my Apple keyboard here. Do a 10. Can you see here how it maps 10 to an event thing here? device node. So what this means is when we have an event which we read through X input, we've been able to get this event node string, which means I guess we can use a hash table, or we can just do a linear search and simply do a string compare or do a not string compare, but just, well, it might need to be, you have to go over anyway, so just do a string compare because it's a null terminated string, right? And just find the device entry that's, got that. And then we can map an event to an input device ID and then send that event out to the user. It's kind of rocket science, but we've figured out a way to do it. So what we want to do is want to quickly attend to our input device. Oh yeah, Akraz, remember when we had that problem? Where when we tried this static and it wasn't initialized? Well, I fixed that. I fixed that now. The issue is my program was overwriting the static memory. Like I had a problem where my Linux backend pointer was, so where is it? Input device. Yeah. It wasn't input device. It was OS. Yeah, it was OS. So we have these sort of like, so to keep it so the operating system header, the operating system implementation doesn't have to be exposed to the user code. We have these. We just basically have an array of plain old data, and then we cast it into the correct type. Now the problem is this backend size wasn't the correct size, and I usually have assertions to make sure I catch this, but in the internal Linux side of things, that wasn't big enough. It was only 8 bytes. So basically we overwrote the yeah, we didn't have this assertion in here. So when we was writing to this data here, we ended up overwriting the static data, hence why that array wasn't 0 anymore. So guaranteed ever do this, it won't crash. There you go, it still works. And my music happened to stop at the same time, making it seem like my computer died. But yeah, that's fine. There you go. It's good. So, hey there, Matenda 3, how you doing? Didn't find just a little tired from today. Fair play. Yeah, I was like that the other day when I was streaming. I was like, could barely even speak by the end of the stream. Yeah, I'm not sure how good Valgrind is when you use Vulkan though, because the problem is the GPU, that the GPU stuff will run and it will just crash in the driver code. Right. Yeah, I could have done it via a pointer instead. Yeah. Yeah, that's not a bad approach actually. Because then the only issue is that it's not sort of, it's an indirection away from the data structure is all, which sometimes matters, but in this case it might not because it's kind of like big data structures maybe, so it might not be so bad. Right, so I think what we want to try and do when I'm speaking with like Joe Mega and No Idea in the chat, they say you want to use the most raw event possible. So the problem is this goes through a layer of translations. I think for key presses maybe not bad. For key presses it might not be bad, but in terms of like for mouse input stuff like this, we probably want like raw motion. And not maybe the X translated motion, I think. Well, if it's in cache, well, that much delay would happen. But yeah, sometimes. But sometimes you have to have a point of being X. Yeah. Yeah, that's right. So I'm not sure about these. I don't know if I want a raw key press or anything like this, you know. Oh wait, I gotta go to the other headers to have a look to see what structure it is. User include X11. Extensions X input 2. Right. So you get this raw event. Yeah, and the issue is you'll get a raw scanned code. Wait, is that right? You get a scan code anyway. Maybe it's fine just to use raw anyway. Wait, what's the bug? Source ID is 0. Is always 0? But we use source ID. That can't be a bug. Because we need that. Oh no, device ID should be it. Maybe. It's not good. Windows, your handle to the Windows literally just a handle, designated pointer. That's good. Yeah, we might have auxiliary data next to that handle that you need. Yeah. Yeah, so I guess what we want to try and do first is get these raw events and just see what it's like. So should we try and do a raw mouse event and see if we can get this to behave? Or should we do a raw key press? Right, so raw motion mask. So we're trying to apply for that. Wait, raw motion. Okay. So which one did we whereas the key press and the button presses, right? And then we did like a click. And the click decided to do some because it was a button press. Gotcha. So anyway, let's sort out these alignments of things. Because I was just throwing code in just to try and get something to work because I copied it from like the X input. Where's the sample from? There's some sample somewhere. Forgot now. Anyway, there's some sample. I forgot exactly what it was on the internet I found. Okay, so I don't know how much of this we actually need. So should we do another one? Yeah, let's do another one just to sort of have a bit of a play with the specifics of raw motion. So for raw motion, you want to get it's not a device event, it's now like a raw event. So let's have a bit of a play and see what that is. And we can maybe add more raw events as well. So let's just print out all of these buggers that we can, or that we want. Right, we kind of just want probably just these three. And, you know, do we want to try and get this device node for it? Should we try that? Because we need to use the source ID, wasn't it? Yeah, because the source ID needs to actually... Oh, on the detail. The detail would be one of those key like codes, isn't it? So when we process like a key being pressed in the old code, we got the X11 key code, which is 8 away from an evdev's key code, which is a scan code. So we get scan codes anyway, so we'll probably just get this evdev code in the raw key input. So maybe we don't need the translate X1 anyway. Yeah, that's interesting. Okay, so what we're going to do, let's look at that raw motion and see what we get. Oh, wait. There's raw values. Maybe there's like a couple of those set. We should see what it's like. Anyway, let's give it a run. So I'm moving it here, it's printing out like crazy. The raw mode. Oh no, it's not. Is that right? Oh, so it prints even if I'm outside the window. Okay. So let's have a bit of fun. There's also a thing called raw values. So maybe let's just pretend like it is actually X. So raw values, let's do 0. And then let's do... Now I'm hoping these are relative or something. Excellent. So it is X and Y, right? That was just a pure guess, because what else is it going to be, right? So the beauty of this is obviously the window manager doesn't support multiple cursors. Yeah, it could be a null pointer, or what's the thing to check? Good point. You know, because they're not references, right? So the thing is the operating system doesn't support multiple cursors. So if you go from the raw device to X11, right? There's and I don't know exactly how this works, right? But maybe X11 like applies it to the cursor, and you're tracking the cursor's position. So if you have two mice moving, is the granularity of the event good enough to sort of like capture two mice moving? You know what I mean? Does it do it for every tiny movement? So by doing it at the raw event level that you get from the actual device, so it goes so I know it's going through the X system is giving it to you, but it's just giving you what it got from the operating system, right? Or maybe in some double thing for some reason, but anyway, it's the most portable format, right? A 64-bit float. So this means you're getting relative things, right? So if it goes right, you get a positive X. If you go down, you get a positive Y. That's wrong. Should be negative. But anyway, up it's negative Y, and then left. So you're getting relative movements, meaning that we can yes, specific to that device. Now we've got a 9 and a 9. Device ID 2 and a 9. It seems like there's two devices being moved. Okay, so let's have a bit of let's do an X input thing. So the optical, okay, so the 9 is the optical mouse, and a 2. 2 is the virtual one. Excellent. So, yeah, this is the one that we actually want. So there's 2 that are coming back, but yeah, we want to like get this one. So if I did like a prop on that and do 2, that's not going to give us anything. But if I do it on a 9, that will give us an event node, right? Right? Event 15. Ba-bam. So that's what we can use. And then we can pump those relative things into the... You should be able to have multiple cursors. Did you try X input, create master new? What's this, Nico? What's this? Please stop. Just wanted to get a quick opinion. I'm making a markdown file with the required API features currently writing down for X11. What do you think of this style? I'll show it to you. Right, is it a bit like you've done like a painting? You're like, which one is better? Because you've just been staring at it for too long. Right, I try that keyboard. I try that X input thing out because maybe you can, right? Right. Currently working down from X from DX12. What do you think of this style to show? Okay, so all right, sort them by like tier 2. Yeah, so if anybody's suggesting by tiers or something like that. I like to keep the actual strut option is defined in. All right. Oh, because it's not references. Oh yeah. Yeah, references there. Tasty. Nah. References like yeah, they raise my core temperature. References. Especially when you have to change from a pointer to a reference or reference to a pointer. Just yeah. I yeah. Yeah, it'd be good to like sort these by tier. Because like having them just yeah, bucket them by tier or something. I reckon. But then the problem is shader model is 6.6 and feature level. Then you got these required features. So you got minimum requirements, and you got required features, I guess. And this one says the structure they're defined in options 3, 4. Right. Okay. But yeah, then not necessarily like it's not really required features though. What it is, also that should be changed to just call it features properly. And there's a required question mark here because it's not necessarily, you know, there's actually whether it's required. You know, there's non-required stuff in here. You know. Hmm. But yeah. Can you select different tiers with your? No, you can't. Can you? So the thing is that you require tier 3 anyway, right? So why are you bothering telling people like, hey, here's the minimum requirements, and then listing all these tiers? Why don't you just say like, our minimum tier that we will ever support is 3 because of these guys here, and the rest is implicit, right? and then there's less stuff to put in, right? Or will this be because there's like Vulkan as well? Is that what you're thinking? So you need to display every feature. Because this only maps to DirectX, right? Yeah, that's my questions. Alright, so that'd be really good. So if it has the property device node atom, then only if we have that do we bother printing. Let's try that, right? That's the DirectX 12 one. I'm gonna have to have a Vulkan one, right? Yeah. Right, so we move it now. Now we get the device node. We don't get duplicates. Oh, we do get duplicates. Why are you there, you little bugger? Why is there a... Oh, because the source ID. Right, so in this case, it's device ID. Let's connect the other mouse to make sure that's true. Right, so now that's only one that's coming through. That's good. Let's get the other mouse in. Here it is. Now what's interesting is would the PS5 controller show up under that raw motion event, you know what I mean? Alright, okay, it's been able to use now. Right, so we've got 13, it's doing its thing, that's good. Do another one, and then there's 9, and there's 13, and there's 9, and there's 13. Can you do both at the same time? Without blowing anything up? There you go, it seems to be, yeah, so there's 13s and 9s being moved at the same time. Cool. Oh yeah. Because support can differ between DX1 and Vulkan on a single card. Feature can be supported in DirectX but not Vulkan. Great. Yeah. Fantastic. GPUs. Oh, yeah, GPUs are the most... Yeah, crazy thing. Known to mankind. So this is something we can roll with, right? This is good. I like it. So we're doing this X motion thing. So that means we'll probably have our own cursors in game. Now, interesting thing is Akraz was saying there's a command that I can run which maybe will blow up my computer. So let's give that one a go. Right, does it blow up my computer? That's the question. No, it just grays out this mouse. And I'm using both mice here. And it just grays out that one. And now I've got one that's just stuck. There we go. If you want... I've done I did dash help and it showed up there. Great. Okay, so it seems like it's done something weird. I don't quite know what it's done. Oh, X input reattach. 13, 16. No way. Whoa. Yeah, obviously we don't want people to do this, have to do this. But look at it. Oh wait, now I got stuck in the corner. What's going on? Oh, so when you move it, you can't... Oh, you can move both at the same time. But I guess the ones that are doing this is simply a inactive one. Or something like that. Right, let's have a bit of a play. Yeah, I have two independent cursors, yeah. Right, so as soon as I move the other mouse, it doesn't like it and stops doing anything. Huh. Second one's on screen. Weird. Oh, yeah, it doesn't. Huh, okay. Well, I promise I've got two cursors. This is not me just... Yeah, so if I begin highlighting with this, so this is the invisible cursor. If I begin highlighting, can you see it? And then if I move the other mouse, it stops. So if any other input comes in, it just doesn't like it. But yeah, X11 people, it might be old, but it has features, and they, you know, it could do things. But yeah, we obviously don't want the user to have to run that to get stuff working or anything. But yeah, that's really interesting. I didn't know that. But yeah, this is exciting. So so what's next is we want to obviously get the raw key presses as well. And then we want to basically wire those in like the traditional, this old traditional one was, right? This old key press, key release, and the mouse one as well. Get those plugged in, and then, like, to be honest, it shouldn't be hard, right? It should just basically be the same job. Our mouse button changed, and then we've got those wired in. We can actually try out the gamepad, right, and get those events plugged in. So that'd be what we're doing next. You want to over-engineered and buggy? X11 is the way to go. Exactly. Well, I don't know if it's over-engineered. It's just they've made like 7 different ways of doing extensions. It's insane. You know what I mean? Like it was designed like in, I don't know when it was designed, but they just kept adding stuff to it. Maybe that is over-engineered. But yeah, so that'd be interesting. Right, so do a quick plug. If you want to get access to the code, bear in mind this code will go up when the whole Linux side is done. If you're a Twitch subscriber, or if you use support on Ko-Fi, which is nicer for me because it's the same price, but they just Twitch takes 50%, so it just sends more to me that way. You can follow that link there on Discord. Join there, and it gives you all the instructions on how to get access to the code. Currently, this input stuff isn't up. When we've hopefully next stream we get most of it finished. But when we've done the proper OS backend for Linux, we'll chuck it all up. I don't want to chuck up something that's half finished. And then we'll be doing a Windows implementation straight away after. So we've been designing this OS backend for to be cross-platform, but we wanted to get an implementation in, right? And there is a VOD channel. So if you're going to catch up on previous entries in the series, they're all up there. I'm going to go and quickly rename the past couple of episodes. Would you consider making some crypto wallets? No. But maybe we should add a blockchain to the game in some way, right? Just the blockchain structure, like the blockchain, like it's a simple enough thing to program, and maybe we can find a use case for it just for the lols. You know? Nah, that's not. I'm not sure what use the blockchain provides. Yeah, we just need some blocks of hashes and chain them all up. Maybe the save game can be done like that, The blockchain save. Minecraft with chains, problem solved. Yeah, we've got to be careful with these blockchains because they can get quite big quick, and you have to follow the. Oh, scary. Because yeah, it's like a linked list of blocks. They've got a bunch of hashes in. Yeah. Maybe there's something we can think about, which we could do, which would just be fun. Just be completely funny. And we've got to try and make it as useful as possible. Right, let's find somebody to raid. Alright, let's raid Jessica. I guess she might be finishing up soonish, so let's just get ready before she does. Right, our next bit on Sunday, guys. Sunday, 4 p.m. GMT +1, and hopefully we can get most of this done now. We've got all the research has been done. We've just been plugging it in, right? And we've got the input device stuff all there. So it seems like we're nearing the end of this, which is good because it's just been a lot of crazy R&D work, right? But yeah, thank you guys so much for coming. It's good to see you all. Have a good Friday and Saturday. I'll see you all Sunday. Radio in a bit. Bye bye. Context of donations, right? I see, Glorious. Maybe not so much. But yeah, anyways, thank yous anyway.